We're going to find the derivative of this function, but before we do so, I would rather not use the quotient rule to take our derivative. I notice we do have that fraction on the right-hand side, but what I would rather do is rewrite this so we can get back to basics and use the power rule. So this just kind of goes back to some of our rules about algebra. What I'm going to suggest is we rewrite this and take that denominator and put a copy under each one of these terms in the numerator. Now why I'm suggesting this is it's a monomial we're dividing by a single term, so we're allowed to do this pretty easily. Then let's think about rewriting this and just reducing down. Okay, we have 6 copies of x in the numerator and 1 copy of x in the denominator. That'll simplify to x to the 5th power, right? That 1 in the denominator cancels out 1 from the numerator, but we still have 5 copies in the numerator. That second term where we have 9 over x, it's x raised to the positive first power right now. What I'm going to suggest is we go ahead and use the exponent rule that says we're allowed to move that up to the numerator by utilizing a negative exponent. So 9 times x to the negative first power is equivalent to 9 over x to the positive first power. At this point, we've rewritten it so we just have x to powers in each one of these terms. So I think it's going to be easier for us to find our derivative dy dx. Or sometimes we'll use y prime, different notation means the same thing. And just go through one at a time. So power rule says the exponent comes down in front, and then you subtract 1, reduce the exponent by 1. So I'm doing 5 minus 1. We're going to get 4 for our new exponent for that first term. That's its derivative. For our second term, again, it's the power rule. The exponent comes down and gets multiplied by the 9 this time. So negative 1 times 9 makes negative 9. The x comes along, but then we reduce the exponent by 1. So negative 1 minus 1 makes negative 2. So our new exponent is going to be negative 2. Now I want to point out this is a good solution in most cases. However, if you don't want to see your final solution with a negative exponent, we could rewrite that by using that same rule we did earlier, in that we can simply bring it down to the denominator and make it a positive exponent. So either one of these, both good derivatives in this case, just different ways to write the exact same thing, different versions of the same derivative. So I hope this helps out as you're working on rewriting these so you can get back to basics with the power rule and taking derivatives. Really just take some practice, but you'll get there.